In this module, you will learn the reasons for testing a confined space atmosphere and become familiar with typical instruments for monitoring. You will learn how to read and interpret information provided from a typical monitor, learn how to set up and prepare an instrument for use, learn how to use an instrument, and learn how to care for and maintain instruments. Let us begin by overviewing the need for monitoring and typical instruments used for this. As we learnt in Program 1, we know that an atmosphere within a confined space can present possible hazards, such as oxygen deficiency, combustible gases and vapors, and toxic substances. We also learnt that in an oxygen-deficient atmosphere, the displaced oxygen can easily be replaced by other gases, and that these gases can cause asphyxiation. The three primary reasons that the atmosphere in a space must be assessed before entry are as follows. Firstly, to determine the concentration level of oxygen. Secondly, to determine if a combustible situation exists. And thirdly, to determine whether there are any toxic substances present, and then assess the exposure limits. Having assessed or sampled the atmosphere within a space, it must thereafter be monitored to provide ample warning to the occupants should a dangerous atmosphere develop during the time that the space is occupied. The instruments required by persons entering a space are generally referred to as personal alarms or gas monitors. These instruments are designed to be carried by the person entering a space and kept switched on at all times for the sole purpose of monitoring in the event of a change in atmospheric conditions. There are various types of monitoring devices, and we shall be concentrating on typical models currently in popular use within industries all over the world. First, we need to explain a little about how monitors or gas detectors operate. In principle, they all draw air into sensors through a diffusion plate. Sensors are made in various types, but in effect they react chemically to airborne substances and then send electrical signals to the electronic circuits within the instrument. Having analyzed the signal, the electronic components then activate a reading on the display screen. If the electronic circuit interprets a reading that matches or exceeds a given set point, then it will activate an alarm signal in the form of an audible sound and with a flashing light. The alarm warns an operator should a dangerous or hazardous atmospheric condition develop. Some instruments, known as multiple gas monitors, are able to detect two or more different conditions or substances, owing to the fact that they incorporate several sensors. Each sensor is manufactured to react to a specific substance or gas type. Another type of instrument is this single gas type, designed purely to detect one known or likely gas. Single gas monitors use only one sensor, designed to detect one type of substance or target gas. Single gas monitors are selected according to the gas or substance